Hello, everyone. Welcome to the binary episode of the podcast. I'm Spectre, with me is Z. Today we have a research post on Windows info leaks, a post on patch capping by Project Zero, and some Apple Neural Engine bugs. As always, though, Z will first cover the Spot the Vuln solution for the week, and I'll let him get into that. I think you might be muted, Z, just as a heads up, because I don't hear anything from you.
Yeah, my apologies. I was muted. Yeah, so we have a bit of a problem. I have in our show links here the wrong Spot the Vault link. I've got our last week's one there, so I see Rudemal saying you can't hear me. I see myself going through OBS, so I think I'm good now. It might just be a bit delayed. Anyway, with the Spot the Vault, unfortunately, I'm not going to have it on screen. I'll fix the link for the actual show notes. Um, what the issue was is we had that regex effectively just doing a. Actually, let me grab the link out of our Spot the Vuln channel.
I have a picture of it. I think I brought it up.
Thank you.
Yeah.
Yeah, I will pull that up. Yeah, sorry about that. I thought I had everything ready to go, and here I'm making these basic mistakes like uploading the wrong video today. um, and obviously wrong Spot the Vuln. So anyway, line 4, you've got the regex doing the API, and this is similar to one we had before where the issue was the presence of the periods inside of the regex. You might, or a developer might forget to escape them. Backslash dot, or putting it just the period instead of a backslash period. What matter, or why that matters, is if you only had the period, that is a wildcard. It'll match any character, so you need to escape them. Now, in this case, in JavaScript, TypeScript, presumably things kind of built off of V8. I don't know if there are too many other languages really going or built off of JavaScript, but at least JS types and TypeScript here, what they will end up doing is if you try to do a backslash escape on a character that doesn't need to be escaped, so usually, you've got your normal escape sequences like backslash n for a new line, backslash r, carriage return, backslash b, backspace, things like that, or, escaping a quote, all of that. Backslash dot doesn't mean anything. It's not an escape sequence. You don't need to escape that there. So the language can choose to do a few different things there. What JavaScript does is it just gets rid of the backslash. You wanted to print a period character, you've printed the period character, or it doesn't know why you included the backslash, and just drops it. Which means you're in the same place as the older issue. You're not escaping the periods as they go into the actual regex string. Other languages do behave a bit differently here. PHP, Perl, Python, Ruby, they'll all include the backslash. Java, C#, they go the route of just giving you a warning or an error when compiling like this. So JavaScript does seem a little bit unique in including the backslash here. So yeah, it is a little bit of a surprising result. Or a surprising thing to see, because it does look okay. But yeah, in this case, in JavaScript, you would want to do double backslash here. Oh, you'll get this same behavior in C and C++ if you're doing regex there too.
Yeah, I said this to Z yesterday before we started our podcast yesterday, but I took a look at this one and I was like, okay, well, it has to be like the dot thing that we've talked about before. Like, I don't see anything else that makes sense here, but it is being escaped. So I had to like do a double take on what the actual issue was, because like you said, it looks like it would be correct unless until you consider that there's like another layer that the escape sequences have to go through. So. Would it work right using single instead of double quotes, or do they have that behavior the same in JavaScript? That's a good question, actually.
It behaves the same way. In JavaScript,
Okay.
JavaScript doesn't run a different interpreter for single or double quotes. That's something that I think Python does it. Perl and PHP and Bash all definitely do different things with quotes. I think Python does too. Not sure about Ruby. That's really something they tend to do. I guess JavaScript does have the format strings now. Okay, Sean Pessy says, I don't think Python does. Um, Fair on that. Yeah, it is. It varies from language to language. Um, where you would have different interpreters depending on the string type. But yeah, I just checked it in a console here for JavaScript. It'll just print the dot instead of backslash dot.
Yeah, it's not something I've ever like. I don't write a lot of JavaScript, but when I have, it's not something I've ever needed to worry about. So I wasn't sure on that behavior either. It was a good question, I think. But yeah, something interesting to think about. And yeah, a bit of a tricky challenge this week.
A little bit tricky, but I mean, you don't have a lot to go on with this one. There's only so many places the issue could be.
Yeah. All right, so let's get into our first topic, which was a bit of a last minute ad as a Humble Bundle book deal came out. So we cover these every now and again when they're security relevant. This one is Z spotted it, so I'll let him talk about it. I thought there was mostly older books, but it seems like there's some newer ones here too. So
Yeah, it's a mix. There are some old books like the IDA Pro book and Practice of Network Security Monitoring. Those are both close to 10 years old. Art of Exploitation's in here. That's, 2008. Um, but most of these books are like 2020 and newer. There's nothing super exciting here. I don't think, especially on the binary exploitation side, there have been a lot of really exciting books coming out. But some of you might be interested. Practical IoT hacking. I mentioned this last no Starch hacking bundle. It was in that bundle too. It was just a surprising book. It had a bit more depth than I was expecting and just breadth of topics. I was expecting just um kind of easier IoT things, but it gets into like the radio hacking, gets into doing some of the hardware level stuff. It's actually an interesting book. Rudimal mentions, to be fair, I don't think IDA has changed that much 10 years. Yeah, when I was writing up a quick Reddit review on these books, um, I got to the IDA Pro book. I'm like, has IDA really changed that much? I think it could still be relevant. It's old, but like it has there's been some UI changes, but they've been pretty stagnant.
other than
Um
breaking the API every other version,
yeah.
IDA's pretty, you know, pretty
Yeah,
stagnant. Yeah.
I mean, I do say stagnant. It's a lot of like those small iterative fixes that really adds up over time. Um to kind of their final product. Car Hacker's Handbook is kind of one of the interesting ones to me. I don't know if it's super dated or not. I don't think the automotive industry is really moving that quickly, but I think it's about 6 years old now, so it's definitely on the edge of where it might not be relevant anymore. Ghidra book's pretty new. I haven't read it. I've generally heard good things. I haven't heard anything like crazy negative about it. Uh and then ethical hacking, very beginner focused, but it's not a network penetration testing intro to hacking book. It goes more abstract, talks about fuzzing and stuff. A bit more broad than I was expecting it to be. Also part of the last bundle, so I'll mention it. But if you've already bought the bundles before, you've probably had that book. So yeah, I mean there are a few books here, and hardware hacking handbook. I didn't realize Bunny did a new book, The Hardware Hacker, in 2019. Uh, so yeah, I mean there are a few books here that might be of interest. Some that are a little bit silly, like Cyber Jutsu. Um, I mean, it's gimmicky. It's got the gimmick of the cybersecurity for the modern ninja. Read the summary, you'll kind of get what I mean on it. Um, yeah, I mean, there's books here. I For $30, I don't think it's that bad of a bundle. I guess 39 or $40 Canadian. Um, if you're on the bounty side of the fence, hacking APIs, I've heard very good things about. And probably would be worth the price just on that alone. But yeah, there are some books here. Art of
Yeah. Well,
Exploitation, but we don't actively recommend that anymore. But
yeah, we have a whole video dedicated to that book.
yeah,
One that I'm kind of interested in is the hardware hacker. The ones by Bunny. I don't know. It's just something I've been getting into a little bit recently, and there could be some cool information in there. I might check it out. But yeah, I
yeah,
mean the
that
humble
one.
bundle. Oh, go ahead.
That one goes into like factories, manufacturing of the chips and everything. It seems super in depth on that side.
Neat.
I was familiar with like his old hacking the Xbox book. Um, and that's just kind of what I associate seeing Bunny with. So when I first saw this, I think I kind of overlooked it. Then I was just looking, and it's relatively recent too, 2019.
Yeah. But Humble Bundle's always nice to take a look at to see what's there. It's cool where the money goes to charity, or at least partly. Um, and yeah, sometimes there's some good books in there, and you can kind of pay what you want to some degree, depending on how many items you want. Um, in fact, like the hardware hacker one is in the 8 item bundle. So yeah. All right. So with that out of the way, I guess we'll get into some of our topics. Our first one here is on the Windows Internals blog by Arden Jafir, and it's titled "An End to KSLR Bypasses." A little bit of a clickbait title. It's talking about like ETW events and trying to prevent the easy info leaks through that way. Z, I'll let you get into this one.
Yeah, and I'll be honest, I really wanted to cover this only because of the clickbait title. Um, I guess there's maybe been an update. I did not see that. I think I saw this before any update was written. But yeah, an end to K ASLR bypasses. Definitely not. What this is really talking about, and I mean, if you actually give this a read, basically, like antiviruses, threat intelligence software will be able to hook events on the system and know when certain sensitive uh APIs or syscall API calls or syscalls are made that would allow for leaking kernel pointers. Because Windows just lets you do that on demand. So it'll basically let things know those are happening. In theory, like an EDR could react to that, see that it happened, and then they can't block the actual request. Like it's not hooking it at that level, but they could say kill or terminate the process or something. I suppose if they saw it happening, but I don't think that's going to happen too soon here. Um, and in fairness, they do admit at the end, like, no, this isn't really the end of the API based uh bypasses, but yeah, I more want to call it out because it has that very sensational title, kind of proposing that there may be an end to bypassing kernel ASLR, and really this is more like you could maybe hook it and do something about it, but there are legitimate reasons for calling those APIs, so have to be aware of that. You can't just block them or remove them.
Good guy Windows syscall is always there to make sure that they're on your side in the fight against KSLR. Uh, yeah. For those that aren't like fully familiar with what we're talking about, KSLR, it randomizes the address space. You have to leak pointers to be able to know where you are. Fortunately, because of Windows and its legacy history, there's a fair number of syscalls where they will just give you kernel pointers in the output buffers. To use directly. There's a bit. It's the line between user space and kernel in Windows is a little bit more blurry than it is in other operating systems. There has been work to address that and try to reduce that over time. But and I think to be fair, I think a good number of those syscalls are sandboxed off, especially to things like browser. So it's not quite as easy as it might seem looking at these types of syscalls because you might not be able to access them. I think this is kind of a cool idea, utilizing their event system to flag calls to these syscalls and try to detect malicious behavior. Um, Overall, whenever you have something that deals with this kind of flagging and like AV, uh, it's generally not going to be super strong. And like you were saying, like they can't really do much about it. They can notice it and maybe look at killing the task, but uh, yeah, it's gonna be you got to be careful when you're doing stuff like that. Still, it's an interesting approach to look at for trying to mitigate some of those easier KSLR bypasses in Windows. Um, and yeah, like maybe as time goes on, we will start to see uh more strong solutions against these types of info leaks in Windows, but Yeah, like you were saying, like this one is it's a bit interesting to look at, but it's not going to have a huge impact, I don't think, on the
Yeah,
Windows
I
exploitation frontier.
can't imagine it being a huge impact. Obviously, the average user just isn't even running like an EDR. Maybe Windows Defend. I mean, that's not an EDR exactly, it's just AV. But like, maybe if Windows Defender were implementing something against it and looking at this, you might see it. But yeah, I mean, this was really one of those topics that the title made me want to cover it regardless.
Yeah, and it was shared quite a bit, so um, we like to cover stuff like that where we can.
From the title, it's easy to think, if you don't actually give it the read, oh, there must be something Windows is doing to prevent KASLR, and really, this isn't. This isn't
Yeah.
that.
All right, so getting into another discussion-focused blog post, we have Mind the Gap by Project Zero, which talks about some Mali GPU driver vulnerabilities that affected various Android devices that were fixed upstream but didn't make their way downstream to devices, which is a somewhat common problem in Android due to how fragmented the ecosystem is, especially when you have vendors getting their grubby hands all over the code base. Um, so yeah, and it also references a talk of a vuln found in the wild by Maddie Stone back in June, which that had some cool stuff in it. So I would recommend you check that out if this kind of stuff is interesting to you.
Is that the
But yeah,
first con talk? I didn't check it
I
out.
think
So
so. Yeah. So yeah, like this post is mostly a call to action for vendors to ship fixes for these bugs that Jan Horn had discovered in Mali. Basically, Maddie Stone found that vuln in the wild, and then that inspired Jan Horn to take a look, and he found like 5 or 6 more issues. Um, which we won't really go into here, but like one of them, for example, was a bug where you could like dump physical addresses to the unprivileged namespace via the GPU page tables. So there was like those kinds of bugs, and the GPU driver on some devices is accessible to like the untrusted namespace. So it is like a valid target to look at, and it is kind of a juicy target in that way. Um, but yeah, like there were some more complex bugs there too, bunch of different bugs. But the main focus is just that call to action on patch gaps, and yeah, to this day, it still seems to be a pretty big problem. Um, and it's kind of a funny one because it affects both sides. Um, when you have these types of patch gap issues, obviously vendors are vulnerable to what you might consider end days, but there's 0 days on their devices. It's basically like free bugs for attackers or free, VR. Um, and it also makes it annoying, like as an attacker, a little bit because it's like you have to keep track of so many different code bases to know like which issues affect which devices. Um, and yeah, like I don't know if vendors can what vendors can do to improve the situation really, because there has been some effort by Google put in over the last few years to try to centralize the code base, but that's more based around kernel core, where they have the control over it. When you're talking about things like the GPU driver or the chipset drivers or anything like that, um, it becomes a lot more difficult because, like, like I said, the vendors like to customize this code sometimes for their own purposes, add their own ioctls or add their own functionality or whatever, and that can make it difficult to merge the upstream patches into the device, or it can be easy for them to just get lost. So yeah, it seems like that's this is just another case of that happening where there was 4 or 5 bugs that haven't been fixed on a lot of devices, and yeah, I mean it's worth noting that this is still happening, and yeah, I don't know what if there's going to be like some kind of solution proposed to
I
try
mean,
to make this a bit better, but at the moment it sucks.
yeah, it is a hard problem for a vendor who's trying to maintain some feature they've implemented to then need also bring in all the patches. Made a bit more difficult. Some of the vendors aren't clear. Is this a security fix or not? Is this patch that's there something they really need to put in or not? When they don't make it clear that it's a security vulnerability being fixed versus just a random bug fix. Um, I feel like that kind of contributes at least a little bit to the presence of the patch gap. Rudimal asked in chat, I wonder how they find these things in the wild. Generally, when we're talking about like, Google or Project Zero having the findings in the wild, that's something that's been actively exploited. That's maybe been reported by like a threat intelligence vendor as like, hey, we captured this exploit attempt, or this device was compromised, captured this payload, whatever, and you look from there. That is a little bit on the threat intelligence side, so it's not somewhere I have deep knowledge of, but that's my understanding. Usually it's going to be caught by like an EDR type system that's running on device and then get reported around, and that's where Google might be made aware of it. Um, or I
Yeah.
mean, Google has their own like tag, the threat analysis group, so could also be in-house detection of that. But still, the idea being somebody notices something weird going on and reports it.
Yeah, I'm gonna double check, but I think that might have been the sample that they got that had debug information in it too. So it was kind of like it seemed to be like a mistake that it was leaked from whatever threat actor it was. Although I might be thinking of something else because I don't see a reference to it here right now. Um, yeah, but anyway, yeah. Sometimes you get samples. Sometimes it's from like detection of behavior and then doing some root causing that way. Um, but yeah, it's more on the threat intel side as the like just like Z. I don't really have a ton of experience on that side. It is interesting. But yeah, not something I can comment on too much. Mostly speculate. But yeah, when it comes to the patch gap stuff, like I said, it's still a problem. It's going to continue to be a problem, especially in the Android ecosystem. And it's just one of those unfortunate things from a defensive perspective for Android, where in iOS or Apple or whatever, security is so much easier for them in a sense, because it's a walled garden ecosystem. Apple controls basically everything in the stack. They control the update system. Like it's pretty easy. But you have Android, where it's like, okay, you have the Linux kernel, which is being centralized by Google, but then you also have vendor drivers for the camera, for the GPU, for the like MediaTek or whatever chipsets being used there, the baseband stack. Like there's a lot of different things that come from different people, and they all have to fit together. And it's kind of a similar issue to what happens with Windows updates. Um, you can see a lot of, or at least it used to be a big problem. It's not as much of one anymore. But you used to have Windows updates that would like break system functionality, and it was like one specific vendor that shipped a bad driver in the update or something. Like it's just a really difficult problem to deal with. Um, and yeah, uh, this kind of just highlights that. So
Yeah, and I guess one other thing that's mentioned in this post, when it comes to the patch gap, is also that approximately 50% of their observed O days in this first half of 2022 were previously patched vulnerabilities. Um, so kind of going with uh, not just the notice vuln, but like the variants of the vulnerability, because they do talk about vendors just not doing like a thorough root cause analysis of either getting like a partial patch out there. And attackers are going to look, if you already know they've made one mistake in one place, you've probably made the same mistake somewhere else. Um, yeah, it's a valid way if you've been looking for bugs is, variant analysis. Um, although more places are starting to be aware of variant analysis and hopefully trying to do it themselves on their own bugs, but we still definitely have vendors who are just patching the specific bug, or even worse, they're patching the reproducer, but not actually patching the bug, just making sure the reproducer doesn't run anymore. That's,
seen that
good
before.
enough.
Adobe.
Well,
uh,
I think they mentioned actually in here. Um, okay, I guess they're not necessarily calling out, but they had these patches come through, and then in our case, we discovered that all of our test devices were still vulnerable to the issues they reported. Sounds to me like one of those cases of like not a full patch, but it might not be. There isn't actually enough information there. I read it like that, but reading it again, I might have been reading too much into it.
yeah. So we'll get into some vulnerabilities here. We have two of them on this episode, and they're both from the same researcher and hitting the same target area. So it's a little bit interesting in that
Yeah,
respect.
and in terms of the Vulns, this is really just this Muhammad Genom. It's really just his episode here. Both Vulns, and they're both his.
Yeah. Um, So yeah, these were in Apple's neural engine kernel driver. First one here was an out of bounds write in ZinComputeProgram get names from multiplane linear and get names from multiplane titled compressed. Bit of a mouthful, whenever you're getting into like AI and neural engines, that's what you get because the code bases get pretty complex. These functions are basically responsible for parsing procedure I/O, and they will take some arguments such as, the command pointer, thread binding pointer, and output arguments. The last of which is this planes array, where kernel pointers to user-controlled data are written, and another argument, the plane count, determines how many planes are copied into that array. The problem is there's no validation on how many planes a model can supply. So by just supplying like a large number of planes, a larger number than what's allocated for the plane array, you can get kernel pointers to user-controlled data written out of bounds of the planes array, which is located on the stack, which opens a lot of possibilities and routes you can go for exploitation, some of which are touched on a bit in this post. For example, like, using the Stack Overflow, trying to cause a type confusion by smashing some other pointer on the stack with, a pointer to data you control. Um,
This is
you
really
could also
where I
go ahead.
wish they'd have included a bit more information, because you just said like this opens up a ton of opportunities, but I get the feeling, when you have a stack buffer, you're actually really limited in terms of are you able to what you're able to overwrite next, like what's in adjacent memory. They do mention stack canary, so basically you're stuck to what's in your current stack frame. So you're stuck with whatever's right next to you in memory in terms of what you can actually overflow before the stack canary, assuming you don't have some canary bypass or leak. Um, assuming that, so they don't really make it clear what the arguments are that you are able to override and deal with. They just kind of mention you can get a heap overflow, and I think they had, oh yeah, and the type confusion. So like you
Given the way
could
that they
do
word
it.
it, saying that fortunately the total number of planes is entirely within the control of the given model, thus we could corrupt several stack variables without affecting the sensitive areas of the stack, makes me think that there is at least a few different type confusions you could potentially go
Sure,
with. Um,
there is. It's just it's not clear what those are. Is more what I'm getting at. Yeah, there definitely is something here, but you are limited to only those options.
yeah. The other one that Z touched on briefly was turning the corruption into a heap overflow. They don't really go into a ton of detail here. Basically, uh, they abuse the stir copy of a plane binding info or a -1 write to this program create arg struct output object. So yeah, by corrupting the index into that array or whatever, you could get an out of bounds heap write of -1, which we've seen in the past. Things like that could be enough to do something significant. But yeah, there's not a lot of info on like either of these strategies. You kind of have to infer it and look at some of the screenshots of the decompilation, because that's another thing. Like, this is working with decompiled code. There is a bit of RE here, so some of the stuff that we're talking about, the researcher might not have even like investigated super thoroughly. But yeah, so it's kind of an interesting ball, and there's a few different ways you could take advantage of it. I imagine you probably could exploit this. I assume it's doable, though Apple is going strong on the mitigation game, so I could be wrong there. It's difficult to tell without more context, but it's a very interesting subsystem for looking at for exploitation. It seems like it's a bit soft in terms of like low hanging fruit vulnerabilities, which makes sense. The neural engine is a newer thing that's coming. I think it only came with like the M1 chips, like the new ARM chips for macOS. So yeah, I
Yeah,
mean,
we
it's an interesting
haven't.
subsystem to look at. It's got a lot of complexity, and as we've seen before, complexity means more bugs, generally speaking.
Yeah, we haven't had a ton of bugs really involve like corruptions in either neural network parsing or just with neural nets at all. I feel like we have covered it once pretty early on. Well, I mean, we used to cover kind of the neural network bugs in general too, early on in the podcast, but it's not something we talk about a lot. Feels like, that sort of parser is a bit ripe for exploits to occur in them. Because there is the complexity of the models actually being parsed and everything. Although it does seem like Apple in this case, like it does require in order to actually trigger this vulnerability, you do need to give it this model that has more than 4 planes. And in order to do that, every model that it'll run has to come through this A&E compiler service. Now, before the episode, Spectre and I were talking a little bit about this, and now I'm just a little bit unclear on exactly how it's enforced that the model comes through the A&E compiler service. Because it says it's or signed by Apple, I assume that providing some input to the compiler service will then compile a model and sign it. That was kind of my understanding of how this probably worked. I think Spectre thought it might be something different than that. I'll let you touch on it if you want to, but you're effectively left. What I felt like is you needed to be able to get this compiler to actually generate your invalid model, or your not necessarily invalid model. You could probably actually have more than 4 planes, but you would need to have the compiler also do that, which is a bit of a limitation on getting it. Then they just have some sort of bypass vulnerability, which they don't actually talk about here. I think they might talk about in their POC 2020 slides.
They do. I actually have a bit of notes on that, but I was planning to get into that in the second issue.
Okay.
Um,
But yeah, I mean, it's a bit of an ask, but they do have a way to do that. And they do mention that you don't need their exploit to pull this off. So in theory, that means it is possible to get this model generated legitimately also. They just didn't want to dig into all the ML of how to actually craft such a model. It sounds like they're, coming at this from an exploitation side and not like understanding necessarily all the ML model uh internals, which I don't know either.
yeah, and especially like he calls out, like, since the framework is written in C++ with STL, I had no interest in reversing this operation because it'd take forever. Like, yeah, it sounds like it'd be a really large subsystem, and reversing complex C++ like that is just not most people's idea of a fun time, we'll say. Um, so yeah, in this case, like, we're actually in both cases. In the next bug we get into too, he basically took a model that was signed by Apple and modified it with a bug that I'll get into in the next post. Um, but yeah, that he points out that that's not the only way to trigger the vulnerabilities.
Yeah, that said, just before we jump off to the next one, I will say that this does feel like a place where fuzzing could come into play, although he calls it out as these kind of vulnerabilities are easy to find manually auditing, but nearly impossible to catch with fuzzers. So I wish I had a bit deeper of an understanding here, because it seems to me like what you'd want to do is, maybe get like a Corellium device or something you can patch out some of the checks, and then just get fuzzing going on like arbitrary models, ignoring the fact that you need signing or whatever, and then you just have a fuzzer generate. It feels to me like if you have some structure where fuzzing, it should be able to generate something with more than 4 planes. Like that should be something it just tries to do. Um,
My assumption with what he meant there is that it's going to be difficult to generate these models in a way that's useful for fuzzing. But like, even then, like, then you could do like a snapshot based fuzzing thing where you have some existing models and then you just mutate them. So I don't know. I don't really like. I
yeah,
want to say
like
that I disagree with it, but where I'm missing context, like, I don't want to say that I know more than the author here, but
exactly.
I think
It's
this would be an area that you could fuzz, and like I said, these bugs seem like low hanging fruit. So
Yeah, no, that's kind of the key thing. I don't have that knowledge of exactly what these models look like. It's not an area of like expertise for me at all, or much any experience. So like I agree with you. I don't want to say like, oh, I know more, but it seems like something that's just a structure that could be fuzz, that we have that understanding, and I wish I had more of an understanding to understand where the complexities are coming from with this. If it is just the models are very complex, like more complex than your average, JPEG or something, doing that type of file format. Um, Out of chat, Sean Passing and asks, are there guides, techniques to help with C++ RE? Been a super annoying obstacle for me in a number of projects. Um, Many painful nights. I
There are actually some plugins that I'll shout out. I remember seeing one for Binary Ninja actually when I was exploring the plugin repository. There are some plugins people have written to try to simplify C++ RE, or at least like rewrite the IL to make it to be a bit more sensible and remove some of the cruft from the stuff that C++ does. That said, I don't really do C++ RE. C++ is like a big turnoff for me for a target. Honestly, it's one of the reasons why I didn't go super deep on browsers, because it's just like it's kind of hell to audit. It's a double edged knife because what's hard to audit is going to be hard to defend too. So you're probably going to be able to find more interesting and complex bugs in C++ code bases. But yeah, I don't know. I tend to avoid C++ as a rule. I just don't like it. I
yeah,
don't
I
like dealing
mean,
with it.
I've had a handful of projects, like just working as a consultant, that were C++ based. So like I've needed to deal with it. It's never something fun or something I enjoy, so I don't really have any good recommendations on there. Spectre, were you gonna mention those or just add them in the show note?
I'll add them in the show note because I don't have it on hand what plugin I'm talking about. But just take a look at plugins for like whatever disassembler you like to use, like Ghidra or IDA or Binge or whatever. Generally, like because C++ RE is so annoying across like universally, there has been some work in trying to make it less awful. You just have to go out and look for them. And maybe write some scripts up to deal with some of the things like RTII or whatever. Um, yeah, but it's a complex area. So yeah, we'll get into our last bug here, which is again an Apple Neural Engine. It's another out of bounds write. This time though, it's due to a double fetch, which is interesting because you don't really see that too often anymore. Um, so yeah, it's
Although
kind of a
the
cool.
main place you do see them today is shared memory, and that's where we've got it.
Yep. So this one was in ZinComputeProgramUpdateMutables, which is called by patch mutable surface to update mutable procedure information. Somewhat complex code base here, but what's important is that one of the functions that gets called to get the ops info object um, is this ANEC get mutable operation info, and it gets this object from shared memory. And the op count field, you might be able to see in the screenshot of the code. It's a little bit small. Um, but the op count field is double fetched, so it's fetched once on line 91 and used on line 93 to allocate space for the mutable weight array, and then it's fetched again towards lines 110 to 125 to populate the array. So if you provide an op count that's smaller for the allocation and then use a thread to race and change the op count to something larger, you can cause out of bounds write on that mutable weight array. The researcher notes here that this exploit would provide some pretty powerful primitives, as your out of bounds write is effectively two 64-bit values, a kernel address to user controlled data, and a semi arbitrary 64-bit value. So, again, another useful bug that can probably be exploited to some degree. Um, and again, in this specific case, he used his bypass to modify an existing model, but points out you can still exploit this from an app sandbox, and that bypass isn't really required. Um, and the way that bypass worked was a little bit interesting. You have to look at the POC 2022 slides. Um, Basically, it relied on a directory traversal. So the models would get stored in this like cache directory on the system, and the Apple signed ones would be in a particular cache. But you could like it would take a path to the model, and you could just path traversal out to a file that you controlled, and it would load that model instead, presumably after the signature check. It's a little weird. I didn't get the full context because I only had the slides. Unfortunately, with POC, you never get the recordings of the talks. Um, but the slides do have a lot more info on both these bugs and the bypass bug if you're interested. He links off to them in both posts. But
That sounds like a
um,
really interesting bug to have. I mean, I guess we've seen some weird bugs out of Apple before. Like I remember the signing bypass thing, where it was like you got a comment in the XML and you were able to comment out like or I guess it wasn't a signing bypass. It was like a you were able to add permissions or mess with how it interpreted what permissions you had using like a comment inside of one of your fields. So, like, you've seen those kind of higher level bugs in the Apple stuff before, but yeah, I mean, directory traversal isn't what I was expecting when he mentioned having the bypass there. So, I don't know.
Definitely
Fun
not. Yeah.
surprise. Yeah.
Yeah, whenever you hear of like bypassing like something that's signed or whatever, you think it's like a crypto issue or some memory corruption that causes the validation to not validate enough. But yeah, path traversal, it was a surprise to me too. But yeah, some cool vulnerabilities here. Like I said, what's most interesting is the subsystem that they're in and some of the complexity there. There is some missing context, but it looks like it's a good area for further research. So, um, yeah, because like I said, these are pretty low hanging fruit bugs, and they look like they can offer some pretty powerful exploitation primitives. So yeah,
Yeah, definitely an interesting area. Just neural network or like the neural chips actually in general. Hitting them. I haven't seen a ton of research on them yet. I have to
yeah, it's one of
imagine
those
we'll.
areas that's pretty new, like new in infancy, I think.
Yeah,
And
I
we'll probably see more research as years go on.
think Samsung has like their chip for it. I'm not sure who else is really doing it. If OnePlus has one yet or something on the Android
Yeah,
side, I'm not sure. But like, there's a little bit of movement to start seeing those come out on consumer devices. So, bit of a
yeah,
new
it's
attack surface.
it's becoming pretty prevalent in the mobile space, particularly for things like images and pictures. Like they'll use their neural models to, like I think Apple demonstrated it this year for like iOS 16, where you can like circle things in a picture and like remove them. So that's where the innovation is going with mobile, is trying to enhance and give more capability when it comes to editing pictures, and just taking better pictures. So yeah,
Yeah, well, as I understand it, like have the point of having these chips on device is that app creators can bring their own models. So train up a model, do something, and then bring that onto the device and have it run reasonably well. So they can basically bring it to do whatever they want. So like it's an
yeah.
interesting area, and as they get more adopted, we'll probably see more apps doing it. That might be kind of what the in-house purpose is, doing the camera stuff, but I have to imagine we'll see more usages with more apps doing something with it. I
Yeah.
mean, AI is all the rage these days.
Yeah, it is the
I guess
marketing sales point.
crypto is all the rage, but AI is up there.
Yeah. But yeah, an area that'll definitely see more adoption and more research into the future. So this is some of the ground floor research on it.
Yeah, and
All right.
hopefully the same author. I mean, like I said, we're covering two posts, and this is their entire blog, so very much dedicating a lot of this episode to them. I hope we get more out of them. Like I said, there were a couple areas that wasn't super clear about in their posts, but on the whole, I mean, a couple interesting bugs nonetheless.
Yeah. All right. So that's all the topics that we have. So unless you have any last minute thoughts, see, we'll go ahead and wrap up the episode.
No shout outs.
All right, cool. So that's everything that we have for this week. Thank you, everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. Quick reminder that in 2 weeks, we will be going on our break and we won't be back until January 9th and 10th. And we'll be going on break on the 12th and 13th. So just wanted to give a quick heads up for that. And yeah, with that said,
Okay.
we'll see you next week.
12th and 13th, I believe, are our last week's doing episode, so breaks after that.
Yeah. Yeah. Good clarification. But yeah, we'll see you next week.